Okay, hi everyone. So my name is Daniel Roos. I am one of the co-founders of Njorda, a small fintech. But before that, I worked in the finance industry at banks and system vendors for about 20 years, mainly using Python. And that's the reason for this talk. I've seen Python used for like a lot of interesting things, really good opportunities for jobs, really good opportunities to sell products to big companies with a lot of cash. A lot of this is not super well known because the finance industry can be a bit complex and it can also be a bit secretive, as we'll get to. So goal today is to do a deep dive into this vertical. So leaving machine learning behind a bit and instead focusing on finance, but how Python is used there. Hopefully you'll learn something interesting and maybe come away with something that's useful personally too. At the end, a demo if there's time to do some kind of trading strategies. First off, finance. What is it? Very briefly, you can think of it as three things. Banking, everything with money, loans, making payments. Asset management, everything about making money grow, but this is also like a routing function. It's the magic that you have some money left over, you put it into your account somewhere, it goes into a fund, and suddenly a brick factory in New Delhi can buy a machine, make more bricks, make more money. So like a global routing function. Insurance, all about risks, pricing risk, spreading them around. Essential for like every person and also businesses. Okay, then there's this guy. Like all businesses, when there's money involved, people get greedy. So finance, there are elements, there's been scandals, crashes, but if we step away from that, finance is essential infrastructure for our society and for like making things work. So the first thing I'd like to highlight is finance is big. It's bigger than most people think, both in terms of size and impact. So let's get concrete. This scary diagram is a map of all the 500 biggest stocks in the US. The size of the squares is like the market cap of the company, how big they are. So you can see Google, Microsoft, Amazon, Apple, like the really big blobs. This part here, about 20%, that's the finance industry. This part basically deals about moving money around to help all the other businesses do their jobs. And it's bigger than consumer goods. It's same size as healthcare. So when we say the finance industry is big, just remember this picture, like 20%. And then why should you care? Well, like I mentioned, there's interesting jobs. Got some stats from before, 12.5%. But since the revenues are so big, they're actually quite lucrative jobs. So 26% of all corporate profits. Okay, maybe you don't want to work in the industry, but you are making a really cool new machine learning product. Like your customers, a big part of them are going to be finance. And they're also customers that have big budgets for IT. Recent survey, 2018, finance spends $440 billion on IT. 30% of that kind of goes in-house, rest out-house, and it's growing. Finally, the one I mentioned, personal finances. Like, if you're really talented, you come out, you work super hard, put all your money in the bank and retire. Not the smartest thing. If you do the same thing, you work 2% less, spend those 2% managing your money in a good way, you could like maybe double what you retire with. So not doing anything about it is shooting yourself in the foot. So that's just good to be aware of. Everybody has to be involved in finance, so you might as well know the rules. And it can be really fun too. Now, okay, that was finance. So back to why we're here, Python. I'll highlight some areas where I've seen it used in like interesting ways. First one, trading and risk. You've probably seen these kind of pictures on the news. There's like this big trading floor at a bank, and they're asking them about the economy. These guys are trading commodities, FX, currencies, etc. First thing you might wonder, why do they need like 12 screens? I have no idea, I've been there. They don't switch things very well. Second thing, what are they running there? It all looks like Excel. What are they doing there? What they're running are usually trading systems. And these are systems that are really complex. They're actually too complex for the banks to build themselves. So there's a couple of global vendors that build them. These systems handle like all kind of calculations, huge amounts of data, and in super real time, like, millimicrosecond. They are millions of lines of code. Parts of it have PhD level math, and they're super expensive. It can easily be $2,000 per user per month. And they need to be customizable. So the one I'm super familiar with, it's Front Arena. It's built here on Södermalm by about 200 developers. Originally Swedish software, now US company. And back in '99, they made the decision, like, we need to customize this, we'll put in Perl or Python. So luckily they went for Python, which was a good long-term bet. And nowadays, like, a brunt of the business logic is developed by Python. This company has courses where they teach people in finance how to use Python, 1,000+ people certified. So more technically, Python embedded in a C++ application lets you combine the raw speed of like C++ with the ability to go to a new market and then customize how trades are priced or local workflows. Python code is stored in the database, so you can do changes instantly. You have a solid application delivered by a vendor, you push new Python code into the database, and things update in real time. Now moving to the secretive parts. I said some parts of finance are not that kind of well known. You have the hedge funds and the quants. The idea here is to beat the market and make money. So basically you're saying we're going to figure out some mispricing and we will just make money. We will look at data, have lots of ideas, evaluate them, and then make better returns than investing in the stock market. And of course, if you know how to do this, you're not going to tell anybody, because if everybody does it, there's no money to make. And these are, like, they invented big data before there was big data. They're all over machine learning and AI, exactly when it was happening. And this can be things like taking, crazy stuff, like taking aerial photographs, counting cars in parking lots with some kind of algorithm, and trying to figure out if the store is doing good business before the report comes out. So like really fun stuff. The little picture on the side here, the like horrible, ugly web page, is a company, I think second biggest hedge fund. They manage $110 billion in assets, like super sophisticated company. And their website basically says, hey, we manage money, no email, no telephone numbers, just an address to send legal documents. So this is kind of the way it works. And then you can read forums and stuff and figure out which ones are good, which ones are not, and what they're hiring for, etc. And that just one anecdote there, because hedge funds are fun. When you think speed, like Python, they will typically use Python to develop the algorithm, then they'll recode it in C++ to be fast, because Python is slow. And I'm going to state that regardless of like what libraries or PyPy or whatever, in this context, Python is very slow. So the normal cycle is Python, code it to C++. If it's very time sensitive, you code it in hardware, so you build an FPGA. If you're doing something that's geography, so you could say that we're going to arbitrage between London and Frankfurt, so kind of trade the same things in two places and kind of find mispricings. They will build these networks. So the map you see there of Europe is microwave towers. So light travels faster as microwaves than in optical fibers. So if you can go from London to Frankfurt faster than anybody using a normal internet line, you can beat them, and you can make like a profit. So it's like 3 or 4 companies that have built the shortest path they can find of microwave towers to cut a couple of microseconds and kind of achieve an advantage there. So that's like the final level when you're going to be really, really fast. It's not all dark magic, though. You can actually try this out. So people discovered crowdsourcing, and that there's a lot of smart people out here that can apply new techniques to solve these problems. So here's 2 companies, and they basically work on the same premise. They give you like all the tools, all the data. You can write up an algorithm. So maybe you think that if I buy a stock on Monday and sell it on Friday, it's always going to be profitable. Yeah, exactly. It's a bit harder than that nowadays. Then they backtest that, and then the magic comes. If your algorithm looks good after all their like testing, they will run it with real money and give you like 10% of the profits. So like 0 risk for you. If you think you can beat the stock market by writing algorithms, and it's all in Python, by the way. When they needed to do this, they picked Python to like be the language that they roll out to people to quickly and easily learn and then build algorithms. So good, fun thing to look up at home. Also just a very good example of how you can use Python to provide like a very high level API, like do something with stock trading. Switching track, open banking. Met some people who mentioned this at lunch, so it's getting well known. So regulation changes. The governments have realized that your data is very valuable and it shouldn't be locked up at the banks. So we recently got laws called PSD2 saying that the banks have to share their data, make them available via APIs. Then you get new companies coming up around this. One company is Tink. How many have heard about Tink? Okay. Located over there by Centralen. For the few of you who hadn't heard about it, they make an app that looks at your spending and basically tells you you're spending 3,000 kronor on coffee. And then you can make a decision if that's good or bad. I guess they're using Python, so I interviewed them, and sure they are. They're a typical ML case. They use Python. What they appreciate about it is like that it's easy to get people started, great ML support, and that they can also roll out the same models in production. So it's like develop good deployability. Not going to get into that too much. It's basically a rehash, but good example of where this is happening. Last use case, I'll pick our own company, startups. So when you're a startup, you have to do a lot of things with little resources, and you need to be super efficient. So what we do, we're called Njorda. It's similar to Tink, but it's for your finances. So coming from the banking industry, we want to tell people not to get ripped off. So we built an app that collects all your savings, pensions, and investments, and then analyzes it with like professional risk. And so you can see like what's happening, what you could do, how you could save on fees. So Tink for your investments. But to do this, we needed to like collect a lot of data, clean it up, manage complex data models, serve APIs, and do really fast risk calculations with a team of 6 people in 6 months. So then we reached for Python, and which has really great support for this straight through. Talking to other startups, pretty much every startup I've seen here or advised in the fintech industry has Python elements in it. So very, very good penetration on new companies that can choose a fresh stack. At the banks, you still have COBOL, et cetera, for legacy reasons, but if you're doing a new company, Python is very, very much going to be in your focus for finance. Okay, those were like a couple of use cases. That was to give you a flavor. Now let's step back and summarize. So I'm saying Python is kind of used everywhere. Why is this? What makes it interesting? First one is actually like really, really old school. It's that Python is easy to learn. I couldn't find a quote, but I believe it's designed to be easy to read and that a developer should be able to pick it up in one day if they know another language. There was a bunch of like early initiatives around this. And since early competition was C++, Java, etc., which are much more difficult, this was an advantage. So back in the 2000s, when I was working at Frontrina and selling this trading system, we were coming into like big banks and telling them, you're going to have to learn this language called Python. You've never heard of it. And then we do demos and we do live coding, and they see, okay, I understand what's happening, and they pick it up. Something like C++, Scala, Haskell, etc. While great languages have a big learning curve. I think the old slogan, batteries included, is still true. And Python's also been called a glue language. So this is less glamorous, but typical bank, this is kind of like a system map. It continues for quite a bit. So this is like 50 systems. There's a lot of glue. You need to parse some XML file, call a SOAP service, put it all together, send it up on an FTP server. And you're behind a firewall, so you can't access the internet. And to get a package delivered, you have to have IT screen it, which takes 2 weeks. So then having a language where everything is just built in, it just works, you can deploy it, huge advantage. So just simple work, get stuff done, is a big value in a big, complicated organization. I think this is a big one. So good, mature libraries for the numerical and scientific. I think we've already seen Pandas and NumPy all over for the machine learning. They actually started their life for finance. So Pandas came from ACR Capital Management. So kind of like a hedge fund that needed to do a lot of time series analysis. And that's one reason it's like perfectly well suited. It handles like filling missing data. I'll demo that. But also handles like weird stuff like proper business day handling. Super boring, but if you actually need to do something and you're working against London and New York, you only want to look at the dates that are business days in both countries. So easy stuff to filter out there. Not covered by like your standard date libraries on many platforms. Specialized ones, we talked about like the algo trading. So there's like really good libraries for doing robotic trading, etc., that come from these companies I was talking about earlier and have been open sourced. And finally, really good Excel handling, just being solid on the basics are a big plus. Speed, I said Python was slow, it is, but embedding C++ lets you add speed where it's needed. That's why NumPy is really fast. It's using specialized compiled, I think it's MKL Intel library. looking on other platforms, I've tried to do similar things in like Scala and Java. You kind of it's possible, but the compile things are horrible. Instead of just having a pre-built library that's like super optimized, super fast. So as long as you vectorize things, Python can stretch further than you think. Talked about embedding already. Future here, I've seen a lot about Python, Numba, etc. Not seen it used live so much, but there's some exciting parts here about actually being able to write things in Python and then having it be really fast. So it looks super promising. Haven't seen it live that much. Okay, not rehashing this one. ML AI, of course, super big in finance. There's like a bunch of great use cases. I'll just say one thing, that this explaining why a model does something is extra important in finance. It's very, very compliance heavy, very, very regulated. So if you say no to somebody about a loan, and there's any risk that your AI is doing this because of gender or race or something, huge problem. So grab me at a break if you want to talk about it, but of course, this is a big area where Python has a big lift from being strong in the ML space. And then, so this isn't totally one-sided, so why not Python? Python, the speed we mentioned, talent pool, it is actually a smaller community, so big, huge thing. We're going to rewrite our core banking system. We need to hire 300 developers. We can get the Java army in, or the consultants can serve us like hundreds of Java developers. Or are we sure we can staff it with that many senior Python backend developers? So I would say this is a breaking factor right now, or like a stopping factor. I've been on advisory boards for startups where people plainly said, don't even try it, go for Node instead or something else because it's hard to hire people. So, but here, talking about big companies. So the more people we get, the better it's going to be there long term. Some parts, like part of banking is like these really big enterprise applications. I think you basically need static typing to have like hundreds of people working on something huge and business critical. I haven't seen anybody build that kind of thing in Python. Not saying it can't be done, but you would need super talented people. So when you need to build something super big and complicated, you tend to reach for Java or something, which is well known and supported for like big project development. May change in the future. Okay, that was the basic slides. Now I want to do an example. So you probably all heard like, don't put all your eggs in one basket, or like if you buy stocks, you shouldn't buy just one, you should buy several. Who's kind of heard that kind of advice? Yes, good. So that's kind of fun. Then you can try that out yourself a bit. So what I've set up is typical example. So using Jupyter, Notebook, want to highlight a couple of things here. Normal parts, importing data. Okay, first one, when you do this, you need data. So luckily, there's a really good library called, it's part of the Pandas data reader. This connects automatically to like a bunch of standard sources. Boom, load Apple data. What did I get? Asking for data for Apple, like the stock price. I actually got a lot of things here. And this is kind of welcome to finance. You have opening price, closing price, high, low for each day. Some other stuff over here called adjusted. We'll get into that. And then, of course, I can get one of them and plot it. So always check your data. So looks great. I have Apple. There's a price. Let's look at another one. So I'll do Visa for a bit further back. You see a huge jump. So what's happened here? Any guesses? Yeah, I heard it, split. Stock split. So sometimes when the stock price gets too high, the company decides we want to make it cheaper for people to buy. We'll divide the price by 7 and give everybody 7 times their stocks. So this will like kill your data analysis. You're doing some prediction, and suddenly the price drops by 7. So of course, there's like people that clean this, and you're actually getting that data for free from these open sources. So it's called adjusted price. So then somebody back calculates this, fills the old data, and you have a like continuous series you can use for analysis. By the way, how many people here own stocks or trade stocks in any way? Awesome. Utility function to just load this data, cache it, give me the close price. Not super interesting. Now let's look at a basket. So I'll take 3 tickers, build a data frame from them. Boom. So not super useful. I'm looking at like 3 big tech stocks here, just because they're familiar names. And of course, I want to look at the kind of relative changes instead. So with Pandas, it's all vectorized. In order to take this and have all these start at 1 and just show me the relative change, it's a one-liner. I take the historical price, divide it by the first row of the prices, does exactly what I want. So now I can see how they performed in 2017, which was like a great year to invest. Google was actually doing worst of them there. So let's say my strategy is I will buy an equal amount of each stock, just to keep it simple. In practice, I would do this like weighted, so you do various percentages and figure out what the optimal mix is, but let's just say I'll go 33% of each one. Then take the returns, sum them up, create a new column, divide by the number of stocks. And there is a glitch, so what the hell is happening here? There's like a huge spike there in my portfolio, it looks strange, and I can see there's a little gap in Apple there. So some kind of price is missing. This is like super typical for finance. Welcome to your day job. So you're getting data from all these vendors, and there's a flooding, or the stock exchange wasn't open, or something happened with this company, and the price is missing. So always like check your data. So Pandas again has really good stuff. Just okay, I want to fill all missing data. I'll just backfill it. I could interpolate or whatever, all built in. So for like an analyst, this makes life so much easier. Boom, now we have clean data. If I hadn't done that, I actually have the old values here. When I estimate the risk for them, I'd be off by a factor 4. So one missing data point would tell me my portfolio is 3 times riskier if I hadn't fixed that. So what I'm doing here is I'm calculating volatility. That's a measure of how risky a stock or a portfolio is. To do that, I need to calculate the standard deviation of the log normal returns, which sounds horrible, but because with Pandas, it's very close to like math. I can basically write log of returns percentage change, boom. And then I can see my expected result that the volatility for Apple, Facebook, Google are 17, 17, 15%. My portfolio is 14. So yes, by mixing the stocks, I get a lower volatility. Great. And you can see that intuitively on the chart. Like the red line here, which is my portfolio, same kind of general movement, but the jumps are smaller. So it's a kind of safer investment. Okay, then of course I want to explore. I'm not happy. Maybe why these 3 stocks? Maybe I have a couple of favorites, but I can't buy all of them. So I want to kind of play around with it. Then a feature I love in here is like interact. So I can build a simple function. This function here basically just grabs a couple of symbols, does exactly what I did before, and plots this portfolio. But with interact in Pandas, I get this. So like a mini dashboard. I think similar to what Plotly was describing, less advanced and built in, but really easy to just get started with. So now I can see the thick line here is my portfolio, and these other lines, I just made them different color, or same color, are the stocks. And here I can remove them. So I can say, well, what if I would just buy Google? Well, my portfolio is going to be Google. If I mix in IBM, I get this kind of thing. So really, really simple way to build something that's interactive, where you can explore and understand different stock strategies. Of course, this is all starting from one date, so that's a little BS. Of course, this year isn't going to repeat exactly, so I should study many starting dates. It's called backtesting. So you take some kind of strategy. In this case, the strategy is buy equal amount of stocks, and you test it for different dates. So first, I can do that visually. I set a starting date here, so I can drag the slider. And as I'm dragging it, I'm getting new start dates. And I can manually scan this and see, hoopla, here's some like interesting cases or things that look weird. Just to build an intuitive understanding of how my strategy would behave had I started on different days. Finally, and this I'll skip through a little bit, I can do something more statistically sound. So typically, once you have your first thing, you'll do a deeper study. So I will look at the stocks, how they really correlate, how they're connected, returns, and then here I'll do a proper, I think I said in the talk, like Monte Carlo simulation. So picking random days, combining them to get a statistical equivalent simulation. This is one way of doing it. So basically I'm picking random days from the past history, like several years history, saying that it's probably going to be similar but not exactly the same. And now we're getting heavy. So it's doing this for 1,000 times, 60 samples, so 60,000 samples, boom. Very fast, because it's all like vectorized C++. And then you can even plot this. So now this takes a bit more because it's a lot of lines. What you're going to see is a chart showing 1,000 different simulations of what this kind of mixed stock portfolio would look like. So getting into the, yeah, here we go, boom, boom, boom. And this is what you would expect. So we're starting at 1, like, same value. Generally, it's going upwards. We have some real extreme outliers. So hey, I could lose, 15% here. I could gain 25% here. Extreme cases. It's a really good way of just sampling and seeing what the extremes are. And then, of course, presenting it as quantiles. So I'm saying like, hey, if I do this strategy, if kind of the stocks have similar volatility, so like a lot of ifs here, but this is kind of the way banks work too, but with a bit more data, then I can be 95% certain of being in this span, and my probable outcome is a 7% return, which is like pretty okay for this period. So that's it for the sample. The point I want to get across is if you just want to play around, you can install Pandas, just grab the data from the standard sources. There's like a ton of tutorials. When I post the slides, I'll put some good links in there. And if you get this orange letter from the government saying like your pension is going to be worth this much, then you can just double check that. Do you like your own pension assessment or stock trading? So before the Q wrap up, finance is really big, 18% of the economy. Python is like used pretty much everywhere there. So as a developer there, you have an extra good opportunity in. As a business, these are probably lucrative customers if you're doing anything with like data, compliance, etc. Python success, it's been like fast to learn, great libraries, and now ML is just giving it an extra boost. And if you think it's interesting, spend some time on it, and just if you learn something and you can ask better questions, the next time the bank tells you to invest in a particular fund, go for it. We are, oh yeah, I have to add that in. We're not hiring because we're a small startup, so currently we're fully staffed, but if you kind of like our mission in helping everybody manage their finances better, talk to me, and we're probably expanding next year. That's it. Thank you.
Wow, we have our first question already.
Hey, thanks for the presentation. So I remember you raised some concerns regarding the static typing situation with Python. I mean, recently they started having some efforts in new things like MyPy and adding some further static checking. And like last time I checked, and I actually used it, it is evolving quite well. But I wanted to ask, in your experiences, if you have seen it on the wild, or how do you see it?
Yeah, so I have not. And in general, I've seen people who work in these places are like super business focused, super busy. So they often don't have the time to do like, the really deep dives and innovations in setting up the latest, newest infrastructure. They'll just grab it, use it, and kind of solve a real problem. So probably not leading edge there, but I do see that as like the long-term solution. Like once they're seeing that Python is all over anyway, then if they can get it stable or like stabilized with something like that, maybe you can build these monster applications on it. And there, I really am talking about like, the army of like 200 consultants all working together in huge builds, that kind of environment.
So any more questions?
Hello. Like finance is really like delicate. Like regarding to if you make a mistake, then a lot of people are going to be very angry. Like how do you handle like human mistakes? Like how do they handle in finance?
Yeah, that's actually a very interesting question because you're right. Like kind of the places I worked, like if some price feed goes down, you don't detect it, you're losing $100,000, like bam. But somebody's going to see your mistake and they're going to trade on it. The kind of answer is, I guess, very carefully and knowing what's important. Like you're doing some kind of internal report, you can go really fast, like, work quickly. You're doing something that modifies the prices you're quoting to the market. You know it's super dangerous, you get a lot of people to check it. So having a very good feeling for when to go fast and when to just be very slow and very careful. and then an enormous amount of monitoring. Also having manual people in the loop. So often we're like, one project we did like a go live, and we had new products going out. And I think we had an awesome team in mid-office, like a third of the deals had to be backed out, but there was a person manually checking things before they went out. And during the go live period, they could do that. And then once you scale up, you remove the manual person. So that's one definitive way.
So yeah, this can be our last question.
Thank you. I would like to ask you, in combination with Python, what would be the second element that you would suggest someone to study if they want to get deeper into the fintech field?
Right, right. That depends on the area. If you're going for like the hedge funds, high frequency trading, C++, that kind of thing. If you're going for like, just more operations, like being really good at Excel can actually be good. I mean, it's used so much that if you have like, superpowers there, it's really good. But it totally depends on where you're going. But for the hardcore stuff, C++, maybe Scala, Java is a good complement. Okay, that was it for the questions.
Yep. Thanks.
Yes.